We have finally made it. We have arrived at the very last lesson of this chapter, and this is not even a lesson that AT or LTF or A Plus College Ready folks gave us. This is a bonus lesson that I'm giving you because I think it's important that you see the algorithm. Today you're going to learn what your parents wish I had taught you on the very first day, because it's going to make finding the answers to these long division problems super easy. It's just going to take away all the conceptual stuff we've been working on. The nice part, you get an answer. But the nice part about what we've been doing is hopefully you understand better why you got the answer you did. So let's get started on this. First thing we're going to do on our notes is we're going to cross out some stuff because, whoa, I don't know what happened there, but this stuff here and this stuff here we're going to get rid of because I don't have a clue what they were trying to do there. We're instead going to do it our own way. And we're going to use something that is referred to as keep, change, let's try that again, change, flip, where we're going to be keeping the first number, changing the second number to changing the sign to multiplication, and then flipping or taking the reciprocal of the second number. Now, reciprocal is a true mathematical term that we use. It means to take the inverse or to flip the number. Let's take a look at the very first example here. You got 1/2 divided by 3. Now, we're not worried about this part right here about drawing the model to support your solution. We have done plenty of that. We're just worried about the algorithm. Now, the way this works is anytime you have a fraction and a whole number involved with each other, you're going to start off by turning that whole number into an improper fraction. So right here, let me scratch those out because I had to restart the video on something. Right here, we're going to end up with a 3/1. The next thing we're going to do is we're going to keep the first number. We're going to change the division and multiplication, and we're going to flip or take the reciprocal of the second number. After that, you're just multiplying fractions, which means if you can simplify diagonally, you're going to do it, but we can't here. And we say 1 times 1, that is equal to 1. 2 times 3, that is equal to 6. And boom, you're done with the problem. That easy. No pictures, no artwork, no graphs, just an algorithm. Now, the good part, that's a really quick way to find the answer. The bad part is it's really hard to conceptualize why the answer is what it is. That's the reason we did all that other stuff involving the visual, what do we call it? Visual model and the area models. Let's work on this next one together too. So I'm going to scroll down on it. And for this one, once again, we're going to make that into an improper fraction. We're going to keep the first number. We're going to change division and multiplication, and we're going to take the reciprocal of the second number. From here, we're going to take and multiply the numerator times the numerator. 1 times 1 is 1. Denominator times denominator. 3 times 4 is 12. Boom. There's your answer. Let's look at number 3 together. So for number 3, change that 5 to an improper fraction. From there, we're going to have 1/4, which we're going to keep, times, we're going to take the reciprocal of the second number, which means it's going to be 1/5. And then 1 times 1, that's 1. 4 times 5, that's 20. Done. Make this 5 into an improper fraction. You can do 3/5. Change division and multiplication. Take the reciprocal of the second number. Now this time we got something a little more exciting going on because we have a 3 times 1, which is 3. A 5 times 5 is 25. Boom. Done. How easy is that? Let's take a look at this last one. We're going to change that whole number to improper fraction. We're going to keep the first term as a 1/5, change division and multiplication, and flip or take the reciprocal of the second number. 1 times 1 is 1. 5 times 4 is 20. Boom. You're done again. This stuff is easy, isn't it? So much quicker than doing those other methods, but remember there was a purpose to those other methods, and that was to help you get a better understanding of why the division was giving us the answers that it was. Let's take a look at this word problem. 3/5 pint of juice is poured equally into 6 glasses. How much juice is in each glass? So what we're doing is we're taking, let me look at that one for just a second. And we're dividing, all right, we're going to divide 3/5 of a pint into 6 equal sections. Take that 6, make it an improper fraction. Then we're going to keep the first term. We're going to change division to multiplication, and we're going to flip or take the reciprocal of the second number. This time, though, we get some bonuses. We get to simplify. When you're multiplying fractions, remember you can simplify diagonally or vertically, but never horizontally. And right here, I can say that 3 goes into 3 once, and 3 goes into 6 2 times. So now when I multiply that out, I'm going to get 1 times 1 is 1. 5 times 2 is going to be 10, which means that each glass is going to get 1/10 of a pint. Now, what if I had not simplified first? If I had done the 3/5 times the 1/6, that would have ended up giving me 3/30, which now I need to simplify. I'm going to do that by dividing by 3/3. 3 divided by 3 is equal to 1. 30 divided by 3 is equal to 10, and that gives us that same answer of 3/10 pints. For your assignment today, you're going to start right here, and you've got a bunch of problems to work, but you know what? It's not going to take you that long. You've got, let's see here, it looks like 3 rows of 3 plus another 4 word problems after that. I don't think it's going to take you too long to knock those out, not now that you know the algorithm. Be sure to be giving me the supporting work that I am showing you, but don't forget how to do those visual methods and area method, because you're going to need to know those on the test, okay? Good luck. I look forward to seeing you in class.